Welcome to part 2 of chapter 5. Okay, let's continue. So, modern block ciphers normally are keyed substitution cipher, normally, yeah? So, we have substitution cipher, but the substitution depends on the key. So, we have key, in which the key only allows partial mapping. So, we don't have actually like A becomes Z in the whole text. Yeah, with the key, sometimes A becomes Z, but the second time you meet A becomes Y. That's why it's, if you remember in part 1, yeah, it's quite difficult to guard against exhaustive search attack if we are using substitution cipher. So to build, yeah, to build why am I this one? Pointer, yeah. Okay. To build a good or to build a symmetric block cipher, yeah, modern block cipher, we have 6 components, yeah, that can make up the modern block cipher. So these are the component. You can have all, you can use some, but you need at least, yeah, 1 or 2 of this to call this a modern block cipher. So let's look at the first 2 that you're familiar with. P box, P is permutation, S is substitution. All right. So P box, permutation box. Permutation, or if you think transposition, transpose, permute, okay? Parallels the traditional transposition cipher. So P box, permutation, transposition, yeah? It transposes bits. It rearranges the bit. So, 2, 4, 5. If you have the letter, the word dream, so D is the first position in the plain text, R the second position in the plain text. So this is plain text, dream. Yeah, this is plain text. The answer here is ciphertext. So R second, E third position in plain text, A fourth position, M fifth positions. Can you see the numbering here? All right. So this is the key. Yeah, this is the key. It says that the first position, the character in the first position in the plain text goes to the fourth position. So D is here. The second position in the plain text becomes the first position in the ciphertext. R is here. 3E goes here. And then A here, M here. So dream, the plain text dream becomes remade. Right? So we have transpose, we have permutes the bits. Okay? We call this straight P box. So there are 3 kinds of P box. I've just introduced to you straight P box. Why is it called straight? Because you have 5 characters in the plain text. So the same size, you produce the same size of ciphertext 5 also. The other kind is compression and expansion. Compression, compress. So from 5, it becomes 3 position only. So 2 characters are missing. We have expansion. Originally, we only have 3 characters. When we expand, it becomes 5. So certain words are redundant. We repeat certain characters. All right? Okay. Let's focus on straight P box first. There are a few ways to represent the key. The easiest way is this one. With the arrow, and you put in your character up there, you won't get confused. You can see it, right? I like this way. But in the book, yeah, a different way of representing it, you can represent it like this. Okay. How do I get this from the arrow here? From the arrow box. Okay. First, excuse me. What this means is, I'm always nervous talking about them. It's easy to get confused. Okay, what this means is the letter here, do you call it letter? The digit here, yeah, the number here, 2. So 25413. That is the position in the plain text. Okay, that is the position in the plain text. So this means the second position in the plain text, the fifth position in the plain text, the fourth position in the plain text, the first position in the plain text, the third position in the plain text. Okay. Now, where is the position in the ciphertext? The second position in the plain text becomes what position in the ciphertext? It will become, okay, here. Can you see the actual position? So this is the first position, second position, third position. So the number here, the second position in the plain text becomes the first position in the ciphertext. The fifth position in the plain text becomes the second position in the ciphertext. Okay, one more time. The fourth position in the plain text becomes the third position in the ciphertext. Right? So, okay. How do we flip from here to here? Actually, this way. Look. You read. You go. You look at the cipher part, the cipher position down here, and then you look where it comes from. So the first one comes from 2, you put 2. The second ciphertext comes from 5, 5. Because it comes from the plain text, isn't it? And then the third position in the plain text, so we are third position in the ciphertext, so we are the third position in ciphertext. It comes from the fourth position in plain text. Yeah? So, but if in the exam I give you this, you change this to this. Can you do that? So how to read this? Yeah? You arrange 1, 2, 3, 4, 5. Can you do that? Yeah. So look here. Okay, try. Let me use a different color. Blue. Okay. So you have your box, yeah. So 1, 2, 3, 4, 5. Yeah, you need to know how vice versa, because sometimes in the exam I give you this, come up with this. I give you this, you come up with this. I give you this, you come up with the ciphertext. A lot of ways we can I can ask you. Okay, all right. So what we do is, okay, I'm nervous. Look, the red one, the first position in the ciphertext comes from the second one comes from, yeah, here. The second, the way you go is you go from cipher to plain text. So second position comes from 5. Third position comes from 4. Fourth position comes from 1. Fifth position comes from 3. So it's the same. Okay, you may pause, you may rewind this, and you can try in the tutorial, and later on I'll give you, after that, I'll give you a homework for you to submit. You can try it. Please practice, yeah, with a P-box permutation, straight P-box. So try from here to here, here to here. Don't worry, open book, so you don't have to memorize. Look at your notes. Okay, so 3 kinds: straight P-box, compression P-box, expansion P-box. So that is P-boxes, a component in modern symmetric cipher. Look, this figure shows all 6 possible mappings of 3 by 3 P-box. And this is a straight P-box because 3 plain text, produces 3 ciphertext. Okay, so you can, with 3 by 3, okay, 3 by 3 means 3 plain text, 3 ciphertext. So we do P times C, yeah? Okay, so these are the different mapping key that we can be produced from a 3 by 3 P box. It can be 213. How do I get 213? Where does it come from? It comes from 2, 2. The second ciphertext comes from 1, 1. The third ciphertext comes from 3, 3. Okay. Again, one more time. The first ciphertext comes from 3, here, 3. The second ciphertext comes from 2, 2. The third ciphertext comes from 1. Okay, why don't you try this? So the first ciphertext comes from 3. Second ciphertext comes from 1. Third ciphertext comes from 2. So these are the keys. So please, yeah, practice going from the arrow to here, here to arrow. But arrow is easier. Arrow is easier because you can put the letter up here. Yeah, I prefer arrow. So for me, it's easier. So maybe it will be easier for you too. So straight P box, 3 by 3. Okay, so this is example, a straight P box. But how do we know this is a straight P box? Yeah, first we'll calculate how many position. So the positions are the ciphertext, yeah? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 times 4, there are 64 position in here. Means, oh, why is my, I want to times. So ciphertext, 64 position ciphertext. How many plain text? The numbers are the plain text. So where is 1? You have to calculate, but this is big, but it's okay. 1, here is 1. Where is 2? You try and find it, but you will also find there are 64 digits in this table. So this is a straight P box because 64 plain text, the numbers, and 64 position, that's the ciphertext. But let's practice. How do we read this table? Yeah, because sometimes 64 is quite huge to do the arrow, right? But practice this. So this here says position 58 in the plain text. The number is plain text, right? Is mapped to position 1. The position is in ciphertext. So 58 plain text becomes first ciphertext. 50th plain text becomes the second ciphertext. This one. 60th, 60th plain text becomes what position? 1, 2, 3, 4, 5, 6, 7, 8, 9. 60th plain text becomes ninth ciphertext. Yeah? One more. 2 more. So 15th, position number 15 in plain text, the number are plain text, 15 is mapped to position 63 because this is 63, this is 64. So position 7 in plain text mapped to position 64, the last position in ciphertext. A lot of practice. You must do a lot of practice to become familiar with P boxes, how to read them. If you're confused, draw the arrow. Yeah? Okay. Are we good with permutation of straight P box? Yes, we are. Okay. Here, we give you the table. We can give you the table this way. We can give you the table in the arrow way. Yeah? But how if we ask you to produce the table? Here we give you the table. Next one is, please design an 8 times 8 straight permutation table. Sorry, 8 times 8 permutation table for a straight P box that moves. Okay, first let's do 8 by 8. Let's do the arrow. Arrow is better, isn't it? Okay, 1, 2, 3, 4, 5, 6, 7, 8. 8 by 8. So in the ciphertext, so this is the P plain text. This is the ciphertext. All right. So same, put the numbering. So it's because it's straight. If it is 8 position in plain text, it must also have 8 position in ciphertext. Okay, first we have that. Then let's read the condition. Moves the two middle bits 4 and 5, yeah, in the input word. Input word means plain text. So they want to move 4 and 5. 2, meaning to the ciphertext. Where is the position in the ciphertext? The two ends. Means bit 4 becomes bit 1 in ciphertext. Bit 5 in plain text becomes 8. Okay, so let me just use a different color. So 4 becomes 1, 5 becomes 8. And then relative position of other bits should not change. Meaning, what's left, you don't change it. If they are first here, and then you just push it. Yeah, so this is the next available one. So just do it this way. Okay, 4 and 5, don't, no, they are already. So 5, 6 is here, and 5 is no arrow yet. So 6, 7, 8. That's what it means, right? So easy. So let's produce the table. This is the arrow. Let's produce the table. How did I teach you? Read from the ciphertext below and then find where it comes from. So the first ciphertext comes from 4. So 4. Second one comes from 1. 4, 1, 2, 3. Okay, we are fourth position. 5 comes from 6. 6 comes from 7. 7 comes from 8. 8 comes from 5. See? Same. Yay. All right. So I hope you really practice what this means, and know how to change from mapping to table. This we call it mapping. We call it just table. But easier to do mapping. If you're given mapping, alhamdulillah, in the exam, no need to convert. But sometimes I ask, please convert this mapping to a table. But if you're giving table, quite confusing. I'm going to stress. So usually myself, I change to a table so that I don't make mistake. I can put the characters, the words above, and then I can easily get the ciphertext. Yeah. If using here, you need a second step. Actually, from here, your brain is doing this. So don't eliminate this to get ciphertext straight away. Why don't you kata zahirkan, you write it down on paper, the mapping, you get your answer, ciphertext easily. All right. Okay, any question? If you have question, pause, write down the question. Later on in the discussion, you can ask me. Looking forward for your questions. All right. So done with straight P box. The second type of P box is called compression. From huge after Ramadan, you slim down 10 kilos lighter. I mean, pray that it's a miracle, but it never happened to me. All right. So I hope I stay straight. I don't expand. Definitely is a miracle if I can compress, but side joke. All right, so compression P box is a P box with N inputs and M outputs. So, yeah, plain text, ciphertext. Because you compress from 32 bits, you compress to only 24 position ciphertext. So we call this compression P box. We call this compression P box. So if 32 becomes 24, there are 8 positions missing in the output ciphertext. So look, the numbers are position in plain text kan? The numbers are position, how many numbers are there in the plain text? The total position is here is the ciphertext. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 2, there is 24 ciphertext position. Because there's 24 position, we are missing 8. So what are we missing? So let's just see. 1, 2, 3. Where is 4? 4, 5, 6. Where is 7? There's no 7. There's no 8. So 7 and 8 are missing. Yeah, part of the characters that are apa nama tu? We deleted lah. Yeah, in the compression P box. So the same way of reading it, just like the it's almost iftar time. Buka puasa. Just like the straight P box. So position 1 in plain text is mapped to position 1 in ciphertext. How about this one? Position 18 in plain text is mapped to position, this is position 13 in ciphertext. Position 31, the last one, position 31 in plain text is mapped to, this is position 23 in ciphertext. Kan? Once you understand the straight P box, easily, yeah, you can understand permutation and compression and expansion. Okay. Yeah. As a homework, why don't you try produce the mapping for this? Can you do that? Yeah. That means you have 32. You have 32. Why not? It's a video. Let us do this together. But let me produce one empty. Okay. So let's have is that a pair? Okay, so arrange this. How many? 32 times 24. 32 times 24. Compression P box. All right. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Maybe this is not a good example because too large. Never mind. I'll do anything for you. Maybe I can make this smaller. Okay. 22, 21, 22, 23, 24, 25, 26, 27, 28, 29, oops, 30, 31, 32. Okay. So I have to make this smaller some more. No. Okay. Can I like, that's the end? Yes. Okay. And then we have up to 24. Let me copy this. So 32 above is the plain text. Then we have the ciphertext here. Yeah? All right. So I'm just gonna give some space here. Okay, so we have 32 position in the plain text and 24 position in the ciphertext. All right, so look here. Okay, let me copy so we can, oops. Copy here, put down here that we can refer. Okay. All right. So let's do this. How do we do this? Blue, red, white, and blue. First position in the plain text becomes first position in the ciphertext. Second position in the plain text becomes second position in the ciphertext. Yeah, I can hear you. Third position in the, here we're doing this. Third position in the plain text becomes third position in the ciphertext. 1, 2, 3. Ooh, fourth one. 21st position in the plain text becomes the fourth position in the plain text. Look, fourth. Okay? 22nd is the fifth position. 26 is the sixth position. Oh, sorry about my arrow. And then 27, 28. Okay. 27, 28. The eighth, isn't it? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. 29. Okay. Oh, all right. After that, it is 13 becomes the 10th. Where is 13? Okay, let me just use a different color. So, okay, start from here. So, 13th. All right. In this case, not all numbers in the plain text is chosen, but all position in ciphertext must, you must have an arrow. So, and then 14 here, and then 17 here. Okay. And then 18, and then 19, and then 20. Okay, we're still going. Another color. 4. So this one comes 4. 4 is 16. 5 is 17. Yeah, 6 is 18. 10 is 19. 11, 12, 13. 11. Oh my God, 13. And then 30, 31, 32. 30, 31, 32. Okay, I repeat. The 30th position in the plain text becomes the 22nd position in the ciphertext. The 31st position in the plain text becomes the 23rd position in the ciphertext. And the 32nd position in the plain text becomes 24th. This is the last one, 24th position in the ciphertext. So this is your arrow. And then when I ask you, please produce a ciphertext. So just write down the original message up here and then see where the arrow brings it. That is your answer in the ciphertext. Okay? Easy peasy. So this is example of compression box. The difference, okay, another one is expansion. Expansion is just it expands. So from 12, it becomes 16. Yeah, from 12, it becomes 16. So why not this? You try and do this, and then if you're not sure of the answer, compare it with your friends in the, or you can ask me in discussion. Yeah. I would like to point out, yeah, because originally you only have 12 plain text position, isn't it? But you expand it to become 16, meaning how can only 12 characters become 16? So certain characters in the plain text has to be doubled or maybe more than once. For example, look, original is 1, 2, 3, 4, 12, but we need 4 extra numbers. So 1 is double. This is the second one. 9 also, we have a second 9. Do we have a second 10? No. 11? No. Second 12? Yes, we do a second 12. And then 2, 3, 4, 5. Okay, we only have 3. What extra numbers do we have? 1, 9, 10, 11, 12. 3. So these numbers are double. 1, 3, 9, 12. That's why from 12, we can have 16 position in the ciphertext. Okay. All right. Tak puas hati. Let's do it. Let's arrange. So because we only have 12, so I can do 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, quite a lot, 12. Okay, 1, 2, 3, 4, 5, 6. Okay, so first position in the cipher plain text, first in ciphertext. Ninth position in the plain text becomes the second position. Then third position, 11, fourth position, 12, fifth position, but 1 has the sixth position. So look, 2 arrows coming out from the first position in the plain text. Yeah? Then second goes here, third goes here, but third also 2 position. So can you continue? Yes, you can. All right. Okay. So now let's try to make you think about another theory, or another is that a straight P box is invertible, means easily invert. Yeah, you can invert from this to this and then can get it back from the other way around. But compression and expansion P box are not, meaning you can get for a straight P box, there's the key, right? The mapping and the table is the key. So if it's a straight P box, if you are given a encryption key, you can invert that key, encryption key, to get a decryption key. So it's invertible. However, for compression and expansion, you cannot get the decryption key. You cannot invert it. Okay, let's see. Here. Oh, first. All right. Hold on. Did I miss a slide? Okay, no. Okay. First, let me show you how we can convert permutation table. All right. The books give you like a proper, but very difficult. It doesn't. I'm not saying it doesn't make sense. It makes sense because it's in a book. Yeah, it's proven. Well, let me just show you a trick, easier trick, right? Because the main thing is you understand how we can invert it. Okay, you understand how cryptography works. That's most important. Yeah, it's not that I want to teach you all the formula, but then you don't know where we use it, how to use it. So let's just focus on our goal is to get you to understand cryptography. First is you understand with a modern cryptography, you must you have a component called P box. And P box, there are 3 types: straight, compression, and expansion. And with this P box, there are keys. Yeah, and only straight P box are invertible. The keys are invertible. The tables are invertible. How can we invert straight P box table? This is how you do it. So this is the original one from previous slides. This is your straight P box, 5 plain text, 5 ciphertext. So plain text to ciphertext. What you do is, the name is invert. So you just flip. You flip this map. Yeah, you flip this map. So, okay, before that, you please learn how to produce the table from the map. Okay, so you have the table from the map, and then you just flip the map. Flip it, ciphertext. Now, whatever is ciphertext, note 1, 2, 3, 4, 5, you flip, becomes plain text. And flip the, but apa tu? Kata apa? Preserve the arrow. Okay, so look, 1 comes from 2. So now ciphertext up. Ciphertext 1 comes from 2. Wait. 1. Ooh. Hold on. Hold on. Okay. Pause there. I just realized, the slide is not right, so I'm gonna redo this together with you. All right. So if let's do the arrow for the invert table, yeah, invert a permutation table. So if 1 in plain text becomes 4 in ciphertext, so now we are ciphertext. So 4 from ciphertext will become 1. Okay. Again, if 2 from plain text to 1 ciphertext, so look at 1 ciphertext because 2, 1 ciphertext, yeah, 1 ciphertext to 2. Okay. 3 plain text, 5 ciphertext means 5 ciphertext, 3 plain text. 4 plain text, 3 ciphertext. 3 ciphertext, 4 plain text. 5th plain text, 2nd ciphertext, 2nd ciphertext, 5th plain text. Okay, let's check our answer. 2, 4, 5. Again, dream. Dream, 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 dream. Okay. So, D is here. R is here. E here. A here. M here. Are made. Okay, is it the same? So R, so this is ciphertext. This is the same character, yeah? Here, ciphertext. Okay. R. So R here becomes plain text. R here. M here. A, 3 here. D, 4. D, 5E. Alhamdulillah. Okay. So there you go. All right. Okay. But what is, this is the mapping of the inverted here. So this is the, for decryption, you use this one. To get back the plain text. For encryption, you use this one, yeah? From plain text to ciphertext. And what is the, okay, same thing. So you read, because this is decryption. So whatever, so now you read from plain text lah, the bottom one. So it comes from 4, 1. It comes from 5. The 4th one, E, comes from 3. The 5th one comes from 2. So this is the mapping. This is the table for decryption. For decryption. Why I said decryption? Because from ciphertext, we get back the plain text. So practice. Don't worry, yeah. But this is very important in symmetric key cryptography, the P box. All right. Okay. So, yeah, compression and expansion, there's no invert. They are non-invertible. Look, yeah, they are non-invertible. All right, because when you compress, you lost 2. Input 2 is lost. So when you try to get back, yeah, inverse, you don't know these 2 comes from where. Yeah, output 2 cannot be assigned a definite value because you only have 2 in the ciphertext. How can you get back 3 in plain text? You don't know, right? Same thing with expansion. Okay, 1 is mapped to 2 input, that's 2 output. All right, so when you try to invert, you don't know whether this one comes from 1 or 2 because this might be letter D, this might be letter something else, right? So you cannot select it definitely. Okay, so they are compression and expansion. So when I ask, is P box invertible? You must answer me back with a question. Which P box? Because there are 3 P box. So only straight P box are invertible. Compression and expansion are not invertible. Okay, so let's take a breather for part 2. We stop at the first component of symmetric key cryptography, symmetric key encipherment, which is P box 3 straight expansion, compression, but only straight is invertible. Compression and expansion is not. And you must know how to convert from table to mapping, mapping to table. Okay, jom. I'll see you in the third part.